Hey everybody, it's Jenny from Norman is Right. Last week I talked about the basics of how pumps work, so let's stay on the topic of pumps and talk about pump pressure basics. Let's get started. When we talk about pump pressures, you'll hear the term head or head pressure. Head is measured in feet. So why would pressure be measured in length, especially considering that the gauges on the equipment usually show PSI? Pump manufacturers know how high their pumps can push a liquid, but since they don't know what liquid you're pumping and different liquids have different properties, the pressure will vary depending on the liquid, but the height the pump can push will always remain the same. So why is knowing the height the pump can push the liquid important? Well, pumps are usually pushing liquid, let's just call it water from here on out, to a higher level in the building. So you need to know that you have enough head pressure to get the water there. Okay, let's scoot this over. NPSH is another pressure term you'll see. It stands for net positive suction head pressure. So let's first talk about NPSHR, or required NPSH. It's the minimum pressure that must be available at the suction inlet. So let's draw our pump right here. And this is the pump, and this is the discharge, and this is the inlet. This is important to know because you don't want to run the pump below the NPSR to avoid cavitation. Cavitation is the point where the pressure in the inlet of the pump gets so low that the water begins to boil. Let me make a little bit more room. When this happens, air bubbles in the water expand and basically pop, damaging the inside surfaces of the pump. Let me make a little more room to talk about NPSHA. This is the available NPSH. This is calculated based on things like installation, elevation, liquid temperature, and boiling point. You want to make sure that the NPSHA is greater than the NPSHR. Okay, let's scoot this over. Another term you'll hear is total dynamic head, TDH. It's the total equivalent height that the fluid has to be pumped, taking into account friction losses in the pipe. TDH equals elevation head, HE, plus pressure head, HP, plus friction head, HF. Elevation head is calculated from the surface of the water's original location to the upper surface of the water's destination. So let me make a little bit of room to draw this. So this is our tank that's going into the inlet, and then we'll draw our pump in here, and then this tank up here is where the discharge goes. The difference between this water level and this water level is the elevation head. Next we have pressure head. Pressure head is the pressure that we want to add to the system or pressure that our pump needs to overcome. For instance, if you're pumping into a tank that is pre-charged with 20 psi of pressure, you have to overcome that pressure as well. So you'll need to convert psi to feet here. I won't get into the details, but for water, 1 psi is 2.31 feet, so 20 psi is about 46 feet. Let's scoot this over one more time and talk about friction head. Friction in the pipes is going to work against the pump and will cause pressure losses. It's very similar when I talk about duct work and the loss due to elbows and T's and such. To make sure your pump can pump the water where you need to go, you need to take into account the losses in the piping. So there are tables that show you the head loss for different types of pipes at different flows. Here is an example, and the table shows the loss per 100 foot of pipe. So if you look at this example, this is a new steel pipe with 60-degree water, and at 10 GPM, it has a friction head loss of 6.81 feet per 100 feet of pipe. So you can see that friction head loss can be pretty big. So now you would take your elevation head, your pressure head, and your friction head and add those all together and get your total dynamic head for your system. And then you would use this to select your pumps, which we'll talk about in a future video. So let's bring all this back on screen. Those are the basics of pump pressures. Don't forget to like and subscribe to our YouTube channel, and thanks for watching.